Mario is going to give you 3 gold coins on the first day. Then every day after that, he's going to pay you 3 times as much as the day before. Then Tony said he's going to give you 3 gold coins on the first day, and then every day after that, he'll pay you 3 more than he paid you the day before. So let's lay this out and see how this is going to look. Let's talk about Mario first. On Monday, you're going to get 3 for a total of 3. On Tuesday, you're going to get 3 times 3, which is the same thing as 3 squared, and that's a total of 9. On Wednesday, you're going to get what you got on Tuesday, which is 3 times 3 or 3 squared, and then multiply that times 3, which is 3 cubed, or 27 gold coins. On Thursday, you're going to get what you got on Wednesday, which is the 3 cubed, times 3, which is 3 to the 4th, or 81 gold coins. On Friday, you're going to take Thursday's 3 to the 4th, multiply it by 3, so we have 3 to the 5th. On Friday, you're going to get a whopping total of 243. If you add all of these up, 3 plus 9 plus Wednesday's 27 plus Thursday's 81 plus Friday's 243, you're going to earn 363 if you drive for Mario. Tony says that he's going to give you 3 more coins than he paid you the day before. So, on the first day, he gives you 3. On the second day, he gives you 2 times 3, which is 6. Third day, Wednesday, 3 times 3, which is 9. Thursday, he gives you 3 times 4, which is 12. And then Friday, he gives you 3 times 5, which is 15. I just want to show you the expanded form here. Oops, let's go back. So this is 3. This is 3 plus 3. This is 3 plus 3 plus 3. 3 plus 3 plus 3 plus 3. And this is adding 3 5 times. So if you can see the difference between the two, Mario is multiplying, Tony's adding each day. So if you add Tony's, Mondays is 3, plus Tuesdays is 6, plus Wednesdays is 9, plus Thursdays is 12, plus Fridays is 15. Tony's total is 45. Okay, so now let's talk about who we'd rather work for. Again, just as a reminder, Mario's total is 363. Tony's is 45. Of course, you'd rather work for Mario because he would pay you more. That's number 2. All right, let's go to number 4. We have this table. We talked about this before we all left on Friday, what expanded form is and what it looks like as an exponent. So remember, 10 is your base, and the exponent tells you how many times to multiply it by itself. So the first couple are done for us. The first one is 10 to the first, 10 times itself once, and that's 10. 10 squared means take 10 times itself twice, and that's equal to 100 if you multiply that all out. 10 cubed is 10 times 10 times 10, which is equal to 1,000. Let's get down to 10 to the 5th. 10 times itself, 5 times is 10,000. 10 to the 8th, gotta write small here. 10 times itself 8 times, 100 million. And then 10 to the 10th. Use it in there. And that's 1 billion. There you go. All right. Let's move to this box. This box is in the middle of page 10. This is pretty important. This is kind of the rule, so you might want to put a highlight through this box. In general, for any number x and any whole number n, x to the n means that you're going to multiply x n times by itself n times. Remember, x is your base and n is your exponent. Again, this is in the middle of page 10. Okay, let's move on to number 6. It says write each expression given below in exponential form. That means write it with an exponent. So a is 6 times 6 times 6 times 6 times 6. So you're taking 6, which is your base, and multiplying it by itself 5 times. So that's 6 to the 5th. 9 sevenths times 9 sevenths times 9 sevenths. And remember we talked about putting fractions in parentheses. So you know that you're multiplying the entire fraction instead of just the numerator. So this will be 4 to the 15th, or 4 times itself 15 times. We also talked about the importance for letter D of if you're taking a -2 to put that in parentheses so that you know that the negative sign is also multiplied 4 times. So this will be -2 to the 4th. Make sure that you use those parentheses because this would be negative, this would be negative, and this would end up positive. -2/3 times itself 3 times. Keep those parentheses, put that exponent up there. So this will, f will be x to the 1, 2, 3, 4, 5, 6 power, x to the 6th. Letter G would be 1 over x, put that in parentheses, to the 1, 2, 3, 4, 5, 6, 7th power. Okay, look at h. H is interesting because we have the 2 that's multiplied by itself 2 times and the 3 that's multiplied by itself 3 times. So that's written 2 squared times 3 cubed. Same for I. We have 11 is the base being multiplied by itself 3 times, and x is the base that's being multiplied by itself twice. So I have 11 cubed times x squared. If you actually multiply this out, 11 cubed equals 1,331 x squared. So J, you have x times itself 3 times and a y. So now I have x cubed y. And when you have variables like that, you put them up against each other with no multiplication sign in the middle. So I have a times itself 3 times, b times itself 3 times, and c times itself twice. So I have a cubed, b cubed, c squared. No multiplication sign there. The last one, L, is r times itself 20 times and q times itself 9 times. when we're dealing with exponents, it's really good to put them in alphabetical order. Okay? So look at problem J. I'm on number 7. Problem J says, what exponent does the y have, and do you have to write it? There's 3 x's and only 1 y. So y has the exponent of 1. So when you have an exponent of 1, you don't have to write it. So this will be x cubed y. It's not necessary to write an exponent of 1. Not necessary to write that down. If you need that to hold the place later, sometimes I do. Okay? Let's go. Let's skip to problem 9. We're going to skip on to problem 9. Now, we already talked about the parentheses. So problem 9, it says evaluate each exponential expression by first rewriting it using multiplication. So the first one's done for you. Negative 3 squared is negative 3 times negative 3, which is 9. This is really interesting because the negative sign is going to complicate things a little. So let's look at negative 3 cubed. It means negative 3 times negative 3 times negative 3. So negative 3 times negative 3 is 9. 9 times negative 3 is negative 27. So if we do this to the 4th power, negative 3 times itself 4 times. If we multiply those together, we have a positive 81. If we go to the 5th power, it means negative 3, which is my base, times itself 5 times. Now, what do you know? We end up with a negative number again. Now let's go to the 6th power. Negative 3, which is the base, times itself 6 times, and we're at positive. One last one, negative 3 times, or negative 3 to the 7th power, which means negative 3 times itself 7 times. So this time we're back at our negative 2,187. Take a minute and look at the pattern that you see here above. See if you can figure out a trick to deciding whether your power with a negative base, what sign it will have. See if you can find a trick. Take a minute. Anybody find the trick? If the exponent is even, your number will be positive. If the exponent is odd, your number will be positive. I'm sorry, hold on. Again, if the exponent is even, your number will be positive. If the exponent is odd, your number will be negative. Sorry about that. Again, if the exponent is even, like 2, 4, 6, your answer is positive. If your number is odd, your exponent is odd, the final answer will be negative. All right, hang in there. We'll get through this together. See you later.